Alright, this is problem 14 from section 13.2. And it's asking for the direction a plane should head in, and an airspeed, or actually a ground speed, if there's a wind blowing it to the southeast at 60 kilometers per hour and an airspeed of 500 kilometers per hour, and the plane wants to be heading east. So we want to end up with, since east is on the x-axis, we want to end up with a vector that is just that, so that all of our j's can't cancel out, and that I is the only thing left, and we want that I to be positive. So if we look at the wind, the x is going to be here, I'll calculate it out. Alright, so the wind is going to have, it's pretty convenient because this is only a two space. There's no ups and, you don't have to think about the plane going up or down. You just have to think about the four cardinal directions, north, south, east, and west. So the wind, since it's heading to the southeast, so imagine if there's an axis, the top being north, so the wind is blowing this direction. And so first you have to figure out these two using the Pythagorean theorem, the two component vectors, and then they're going to have the same value since it's exactly 45 degrees southeast. So find the magnitude using the Pythagorean theorem, and then simply change make it negative or positive depending on which way it's heading. So right now the x part is heading to the right, east, which makes it positive, but the y value is heading south, and so it's negative. So the plan's going to be to figure out what the airspeed. Right now we're going to add up the wind plus the airspeed, and that should equal the ground speed. And so we're going to use the airspeed to figure out the direction, and then we're going to use the ground speed, and that'll be our answer when we find the total magnitude of the ground speed vector, because first we're going to find the component. Okay, so we can ignore these z's since that's all vertical, up and down. And we know that our final ground speed, we want to be heading due east. So our goal is to have our y vector, which is heading north and south, to be 0, because we're not going to be heading north or south at all. We're just going to be heading east. And so now we're looking for this final ground speed. So that's how we get the airspeed here. We know that the y component of the airspeed has to cancel out with the wind in order to be heading due east, so we can set it to be positive 60 over square root of 2. So the final ground speed vector is j. And so now the two things we need to do is find an airspeed x vector that will be, first of all, more than 60 over square root of 2, and we will eventually get the direction from that. But how we're going to do that is use the Pythagorean theorem, because we do know that the airspeed, the total magnitude of the airspeed vector is 500 kilometers per hour. So first we're going to solve for x1, and then we're going to solve for the ground speed. Alright, so you can pause it and look at this algebra here over on the right, but pretty much I just used the Pythagorean theorem to find the x1 value, and now that actually could be negative since we're taking the square root. It could be plus or minus, and that kind of makes sense since all it's telling us is that the airspeed is 500 kilometers per hour. It's not telling us direction, so theoretically it could be going backwards, but then you'd be going west, since this is a lot more than the 498 is a lot more than 60 over square root of 2. But it is positive 498, so I'm going to write that in over here. And then I'll find the direction first, and then the ground speed. So I actually found the ground speed first, just because it was pretty straightforward. You're just adding the wind and airspeed vectors together since they're both x's, and you don't have to do any Pythagorean theorem because there's no y value since it's heading straight east. So this is your answer for ground speed, and then we're just going to use some trigonometry to figure out the direction that you're heading in, that you're pointing in, to counteract the airspeed so that you're heading straight east, or to counteract the wind. Alright, so this is pretty simple. I drew a little diagram here. We're trying to go straight east, and so we have to look at what the airspeed, what our speed is when ignoring, or it's really hard to describe the airspeed, but pretty much this is the direction you're going to aim in. And see this bottom one that I've labeled I right here, that's actually the direction you're going to end up going in, but you're aiming up and the plane is just flying against the wind. So the airspeed is this vector, and we're trying to find theta, which is the angle you're going to take. So you just do tan theta, opposite over adjacent, and this is, I kind of skipped a step here, but it's 60 over square root of 2 over 498. And if you click that into your calculator, you get about 4.69 or 869 degrees. And then this notation here is kind of important since we don't have I's or J's, but it's north of east, and that's because this is going east. I is going east, and so we're aiming a little bit north of east since the wind's coming southeast. So you can imagine the plane flying very quickly a little bit north, and the wind blowing very weakly but very far south, and it counteracting so you go exactly east. So your answer for problem number 14 of section 13.2, the ground speed is 541 kilometers and kilometers per hour, and 4.869 degrees north of east.